binomial, but it's not in descending order, so I have to write x to the fourth minus 1 over 16. Then I look at greatest common factor. There is none. A negative leading coefficient, no. The leading coefficient is 1. Is it a binomial, trinomial, or a polynomial? It's a binomial. It has minus. Because it has minus, I can only look at the difference of squares or the difference of cubes. I cannot look at the sum of squares or sum of cubes. So difference of squares or difference of cubes. Well, this is not a cube. I can't cube anything to get x to the fourth. So it must be the difference of squares. So for the difference of squares, I know from last Tuesday that the difference of squares is a product of two factors, one with plus, one with minus, everything identical. So now I'm asking myself, what can I square to get this, and what can I square to get that? And once I have the answer, I know one will be plus and one will be minus, and they have to be identical according to the difference of squares. So what are they? What do I square to get x to the fourth? What do I square to get 1 over 16? X squared and 1 over 4. Correct. Very good. X squared 1 over 4. X squared 1 over 4. Now I go back because this is not enough. I go back to my strategy and I realize that this is the sum of squares. This sum of squares is not factorable. I can't do anything to it. But x squared minus 1 over 4 is again the difference of squares. And how do I factor that? How do I factor x squared minus 1 over 4?
Which problem is the one in blue marker you got there?
This one?
Yeah.
From the handout.
Example of question 1.
From the factoring strategy, problem D on the first page. It's an example. Similar to number 1. So then this has to be factored again into x plus 1/2, x minus 1/2, and this one is copied as x squared plus 1/4. And this is it.
Okay.
Is this good enough?
Yeah. Can you give me one more example?
Of which type?
The binomial joint.
A binomial? What?
The one that you just did. One more
Yes. So can you wait after class? Because we have to continue.
I hear you.
Yes.
I'll wait.
And I'll do more problems. You can choose for other problems because I need to proceed.
I hear you.
I'll do any problem, but let's continue. Anyone else? Other questions other than with what we just did? Other questions from similar to the ones on this quiz? Is there anything else you would like to see? Other type? Question number 4, question number 5, number 6, any of those? Which one?
Number 4.
Number 4. Okay, so a question like number 4. Question like number 4 would be this will be more difficult, but it's a good example. So this is 4x squared. So 4x squared minus 18x equals 70. So when we try to solve quadratic equations like this one that you have by factoring, if I don't have 0 on one side and don't change it into a product, I won't be able to solve. So then I have 4x squared minus 18x and minus 70. I go through my strategy at all times. Descending order, yes. Greatest common factor. Actually, there is a greatest common factor, and this is an equation, and I can divide by 2. 4x squared divided by 2 is 2x squared minus 18x divided by 2 is 9x. 70 divided by 2 is 35, and 0 divided by 2 is 0. I made my life much easier because now I have to find two numbers whose product is and whose sum is. And you can say you just omitted your steps. No. No negative leading coefficient. It's not a binomial, it's a trinomial. Is this a special product? I wish. It cannot be. Negative 35. 1 is the leading coefficient? No. So it's the very last option. And this is a very good practice. Can anyone give us what will the product be? The product will be?
For the top one, it's 35, right?
The product will be?
I don't know.
Anyone?
Is it 2 times 35?
2 times negative 35. Excellent. And the sum, it will be always? You cannot separate 35 from its sign. You cannot separate 9 from its sign.
And the bottom one is negative 9.
Very good. The sum is negative 9. So let's find two numbers. Again, you can say 70 is a big number, but not a big deal because it's 7 times 2 times 5, which is 10. So this is 2 times 5 times 7. The product is negative, so obviously we want to find, a negative and a positive.
Wait, what would you put in the squares and the triangles for the top one?
So let's find it. We have 2, 5, and 7. We need two numbers whose product is negative 70 and whose sum is negative 9. They will be the same. These two will be the same, and these will be the same. I cannot find 2 here and 2 different here. They are the same. So the square is the same with the square, and the triangle will be the same with the triangle. So look at 2, 5, and 7, and come up with two numbers whose sum is negative 9, one negative, one positive, and when I multiply all these, I will get the negative 70. So negative 14 and positive 5. 2 times 7 is 14, and then 5. When we multiply these two numbers, we guarantee to get negative 70. When we add these two numbers, it's guaranteed to get negative 9. At this point, we remove this term, replacing it with these two terms. And like before, we will factor by grouping. So what will you group? What will you factor out from the first two? Excellent. What is left in parentheses?
X minus 7.
Excellent. I have to copy it. And now I look. I need a sign and a factor. Very good. Without a sign, I will not be able to continue though.
Positive.
Excellent. Great job. The common factor goes out now. Which is?
X minus 7.
Excellent. And finally, 2x plus 5. So that's how we have an x minus 7 to be 0, because it's 0, and it's a product, so we get 7. And then the other one, 2x plus 5 to be 0, we move 5, and we divide by 2. So x equals negative 5/2. One solution, the second solution. The problem in the quiz is much easier because the leading coefficient is 1. Anything else about 5 and 6? If not, I would like to look at solving quadratic equations by 3 other methods so we can continue. Other questions on 5 and 6? They're all the same. You have to move everything to one side, set it equal to 0, and apply factoring. But if you consider we did not do an example similar to any of those, I will. If we did one, I would like to do more after 12:15 with anyone interested. Okay, so then if no one says anything, you can always stop me, right? You know that, always. So I would like us to continue with section 1.5. Solving quadratic equations. And we have 4 methods. Each and every one has a specific applicability. One we already discussed, by factoring. Hopefully we're done with that. Number 2, taking square roots. But only if I have something like this. Whatever squared with x in it or y in it or z in it, whatever it is, and a number here. Then we'll talk about taking square roots. Only in this situation. So for example, in going back to my handout, in this situation, or any of these situations, I cannot apply taking square roots. This one I can. I can apply taking square roots because I have x squared and equals 100. But here I cannot apply taking square roots. In no other situation I can apply taking square roots. Number 3 is completing the square. When do I complete the square? Only when I'm forced to. I will never do this, but it's an important method for something else that comes up in this course. That's why we need to talk about it. And the last one is a quadratic formula. So since this is done, at least for the next 7 minutes, if I could finish up taking square roots. Only in this situation. So I'm back to, I printed out from your, from the book, I printed out just this page from the ebook to take a look at examples 15 through 34 by the square root property or taking square roots from both sides. So I like to start with, let's say, 18. So in 18 on page 167, so we're talking about method 2, taking square roots. We have 3x squared minus 1 equals, no, I'm copying something else, equals 47. Yeah, 3x squared minus 1 equals 47. So you can say you cannot apply taking square roots here, and I'll have to agree. It's not ready for this form, and it's not in this format. But obviously I'm going to add 1 to both sides. I will simplify because remember 2 key words. Key words that we should, or concepts that we should always have in the back of our minds whenever we think about math. And they are factor, and the other one, simplify. These are two important concepts. Moving forward, we should have them in the back of our minds at all times. So having this in mind, I see 3 here and I see 48 here. Obviously, I will simplify by 3 to make my life as easy as possible. And then, I think I'm on page 6. Yes, I'm on page 6. After I divide 3x squared by 3, I get x squared. 48 divided by 3, and I get 16. Now, indeed, the equation is in this format. Something squared with x, or a variable, whatever variable, squared equals a number. Ah, okay. So then I can apply the square root to both sides. Remember, because the degree of this polynomial is 2, we expect 2 solutions. So degree 2 always means 2 solutions. So if I take the square root and I write this, that would be incorrect.
2, x equals positive 4 and to negative 4?
Positive 4 and negative 4. But this makes some of my students draw the conclusion that the square root of 16 equals plus or minus 4. False. The square root of 16 does not equal plus or minus 4. It does not. And then you can say, fine, but then where do the plus or minus come from? Well, we are skipping a step. Skipped step. And the skipped step here is this. The square root of x squared is the absolute value of x. The square root of x squared is not x, is the absolute value of x. So then the equation, basically, the step that is missing here is the absolute value of x equals the square root of 16, which is 4. This equation has 2 options. Because I can put here 4 and the absolute value is 4, and I can put here negative 4 and the absolute value is still 4. So that's how we get x equals 4 and x equals negative 4. But we skip this step. And then students, or anyone could think the square root of 16 equals, it's very clear. The square root of 16 equals the square root of negative 4, the square root of 16 equals plus or minus 4. That's incorrect. So keep in mind we are skipping a step. So then, for example, if I have the square root of x squared equals the square root of 9, this should change into this. And then x equals 3 and x equals negative 3. Instead, we skip this step and we come back and say, x is plus or minus 3. But not to assume that the square root of 9 is plus or minus 3, because that's not correct. Okay.
Answer would be the absolute value. Is that what you write down?
The answer is plus or minus 4. Since I only have 1 more minute, I'd like to show one more problem, like 30. So this is it's 4x minus 1 squared equals 16. So in this case, the same idea, something with x squared equals a number. So I take the square root from both sides and I get 4x minus 1 equals plus or minus 4. But here I have 2 more steps. I have to move 1 and then divide both sides by 4. So then 4x equals 1 plus or minus 4. And then x equals 1 plus or minus 4 over 4. But I have to separate them. 1 plus 4 is 5, so then 5 over 4. 1 minus 4 is negative 3, so then negative 3 over 4. And yes, they can get more complicated.